Static class members. As you may recall, we did introduce the basic concepts of static back when we were discussing methods, and now what we'd like to do is talk about static in a bit more detail and show you how to create your own static members of your classes. So just reiterating, first of all, if you have static fields, static data in your class, we refer to such data as class variables. When you have a static member inside of your class and you create many different objects of that class, all of those objects can share one common piece of static data. So in a way, the static data represents class-wide information, or you might even think of it as kind of global data specific to one class that only objects of that class have access to. And just like regular instance variables, class variables can be declared as private or public as well, and depending on how you declare them, that will determine whether client code has access to those variables. And if you do private static data, as we will do in our next example, that would be a case where sometimes you would provide a static method to enable access to that static data. So anytime you need to have data that's going to be shared by all objects of a class, you would typically declare that data as static. And as a for example, think about defining a video game. Maybe you have a video game with space creatures, and they get more aggressive the more space creatures there are, and they get less aggressive and start to run away the fewer space creatures there are. We'll call them Martians just for argument's sake. So what we can do is have a class called Martian with a static field that keeps track of how many Martians are in the system at a given time, and the larger that value, the more they chase after you, the smaller that value, the more they run away from you. So that way, as we create each new Martian object, we can have the constructor modify the static piece of data, and all the other Martians would immediately know that there's one more Martian in memory, and when any Martian gets eliminated from the system, it can at that point decrement the counter, which is the static field, and all of the other Martians would immediately know that there's one fewer Martian in memory. So you get a general sense of the purpose of a static piece of data when you're using it to maintain state that all the objects of a given class need to be aware of. We also talked about the concept of static fields such as the math class's pi constant, where the key is that we just wanted to define a named constant that has a specific value for its entire lifetime, and because of that there's no need to have multiple copies of it, in which case we can make a public static variable declaration in a class and then access that variable through the class name itself, as in math.pi. So as you know, static fields that are public, like math.pi, are accessed via the class name and a dot operator, and then separately methods that are static are also accessed through a class name and a dot operator. Also, your static members need to be initialized in their declarations. If they're not, they'll get their default values, and that's not to say that you can't modify them later on. As long as a static variable is not final, then it is also going to be modifiable, and you can modify it at any point during your program, which is what we'll do in the next example. One other thing about static methods, and this is important now that we've talked about this reference. Static methods do not have access to this reference, and the reason is that this reference always refers to a specific object of the class, and if you think about it, your static members are available from the moment the class gets loaded into memory, even if you don't have any objects of the class yet. And while you have objects of the class, the static members exist, and after all those objects are gone, the static members exist as well. So when there are no objects of your class in memory, what would it mean to be able to use this reference, because it doesn't refer to anything? So they simply do not allow you to access non-static members from the body of a static method definition in your class. The only way you can access members of an object when you're inside a static method's body is to have an actual reference to an object through which you can then invoke methods on that object. So keep in mind that static methods do not have access to the non-static members of your class and do not have access to this reference. Separately, static methods do have the ability to call other static methods directly. So if you had multiple static methods within your class, one such method could invoke another. Now let's take a look at an example in which we demonstrate the concept of static. Here we have a new version of class employee, and in this example what we'd like to do is keep track of how many employee objects are in memory at a given time. So we've defined a class employee where every employee is going to have two instance variables, the strings called first name and last name, both of them are private, and we're going to keep track of all employees via line 9, the private static integer called count, which we are explicitly initializing to 0, but if we had not initialized this, because it's an int, it would have been initialized to 0 automatically for us. So at the time that we first start our program, obviously there won't be any employee objects yet because you can't create objects in Java until execution time using the new operator. So we'll start with a count of 0 and we're going to output that for you to show you that it's 0. Then as we create each new employee, the constructor for class employee will get called and will receive strings representing the first and last name. We'll use those strings on lines 15 and 16 to initialize the first name and last name instance variables. And then at line 18, we will increment the count static variable to indicate that there's one more employee in memory. Now this variable gets physically stored outside of all the objects of your class, so they all have access to one location in memory that represents the count variable. So this adds 1 to that variable, and notice here that I'm in a non-static method. This is the constructor of the class. There's no static keyword here, but I'm still able to access the static piece of data. Your non-static methods can access all of the data and methods in your class, both the static and non-static pieces. So we add 1 to the count to indicate that there's one more employee. We even print out that the employee constructor got called for a specific employee. We show you their first and last name, and we show you what the current value of the count is after this person has been constructed, and we output the first name, the last name, and the value of count. Now, we have a new feature here at lines 26 through 31, a special method named finalize. Part of this example is going to be dedicated to talking about the garbage collector. And finalize is a special method that gets called automatically for you when the garbage collector decides it's time to reclaim an object from memory. Now, the garbage collector is not guaranteed to execute in every single program unless there's what you might call memory pressure, meaning that you're starting to run low on memory for your program and it needs to reclaim unused objects so that other new operations can create new objects at execution time. It's unclear as you move from platform to platform how frequently the garbage collector will run. It is a separate thread of execution that runs in the background of every program you create, and because the Java virtual machine specification doesn't lay out exactly what every garbage collector must do, whoever is responsible for implementing the garbage collector on a particular platform may choose different collection algorithms. So there's a variety of reasons why this finalize method is rarely used in Java applications, but we are going to use it in this example to demonstrate that we can decrement the count when an employee object is physically removed from memory. And if you define finalize, the first line must look as shown here. The protected keyword is an intermediate level of access in between public and private. And for the finalize method, it's always declared protected. Basically, to client code, something declared protected looks like it's private. So if I go and try to use this class from another class, this looks like a private method of the class, so they can't see it. However, if we were to ever enhance the concept of an employee via the inheritance concept where we extend a class, then we would be able to redefine this method again. The concept of protected is covered in detail in the second of the two courses that make up this video course sequence. Now, when finalize does get called, or I should say if finalize does get called, it's going to subtract 1 from the static count variable, and then it will print out the employee that's being finalized, i.e. the employee object that's being reclaimed from memory, and it will show you the first name, last name, and count, where the count is now how many objects there are going to be in memory after this object is finally removed. So the way finalize works is it's basically a cleanup method. It's a last chance for you to do some cleanup operations before an object is reclaimed from memory. At that point, the data still exists, which is why we're able to do this printf statement. As soon as the closing curly brace of the finalize is reached, then the garbage collector would reclaim the memory. Now, for our employee class, we've also provided get methods for the first name and the last name strings. These are both straightforward. And then at the very end, line 46 through 49, we've provided a static member function. Now remember, our static piece of data called count is private to the class, but I'd like the client code to be able to find out what the current count is. I just don't want them to be able to modify the count directly. So I've provided a public get method, getCount, which is static, and the reason it's static is so that the client code can call this method before any objects of class employee exist, while they exist, and even after they're all gone. No matter what, getCount will always exist if the employee class is loaded into memory, and I can therefore obtain the count at any time. So let's take a look at our test application now that uses our new class employee. The first thing we do in main is we call printf, a systemout.printf statement, where we print out the number of employees before instantiation, that is, before we've created any. And notice how we invoke getCount. And we've seen a number of different static methods being called so far. Remember the math.pow method with capital M, math, for the class math, or integer.parseInt, which allowed us to convert a string to an int, or even the string.format method, which allowed us to invoke the static format method of class string. So just the same way, we use our class name and a dot, followed by the name of the method on which we for which we'd like to call on this employee class. That's going to give us back 0 in this case because we haven't created any employees yet. Then at lines 13 and 14 we create two different employees, E1 and E2. Each is a new employee, which results in a call to the employee constructor. The employee constructor is going to initialize the employee's first and last names and add 1 to the count static variable. So after we've done lines 13 and 14, we've added 1 to the count variable twice, so the number of employees in memory is now 2, and we'd like to print that out for you. So here at lines 17 through 21, we actually print that out for you 3 different ways. In line 18, we call E1.getCount. In line 19, we call E2.getCount. And in line 21, we call employee.getCount. Now each of these is actually calling the same getCount method and accessing the same piece of static data. The problem with these two calls at the ends of lines 18 and 19 is that we're using the employee variables E1 and E2 to make these calls, and that makes them look like they are not static method calls. Whenever you see a class name and a dot, you know the thing you're looking at on the right side of the dot is actually static. So this is actually a poor programming practice, but we did want to show you that regardless of how you call getCount, you're always going to get the same count because it's one piece of static data in memory. Now before we continue in the program code, I'm going to go ahead and run this so that we can see the initial output. And you can see here that the employees before instantiation was 0, and then we create the 2 different employees, and you can see the count incrementing as we go. And here's the part of the code we were just talking about, and regardless of the way in which we invoke getCount, we get 2 as the result. All right, let's go back up to our main once again. The next thing we do is just show you that we can interact with our employee objects by getting their first and last names, and we output the employees' names. And then we get to an interesting new feature where we take the variables that represent our two employees and assign the value null to each of those variables. Remember, these are variables that refer to objects. They hold the address of an object in memory, kind of like the concept of a pointer in programming languages like C and C++. So when you set E1 to null, what you're saying is that this variable no longer refers to the employee Susan Baker. So that employee object doesn't have any more references left because this was the only variable that referred to that object. So in effect, what we're doing here is quote-unquote marking the employee Susan Baker's object for garbage collection. That does not mean that it will get garbage collected. It just means it can get garbage collected. And this is actually a good programming practice in a long-running program. As soon as you know that a variable is no longer necessary, if that variable refers to an object, you can assign that variable null and thus decrement what is known as the reference count on the object. As soon as that reference count becomes 0, the object can be garbage collected. And we do the same thing here for the employee variable E2 as well. Now, when I first wrote this program, I didn't fully understand the concept of garbage collection. So I thought that as soon as we did lines 31 and 32, those objects would get garbage collected. In reality, they did not get garbage collected, and in fact I left the program up and running all night long and they still didn't get garbage collected because there was never any urgency from the Java virtual machine to say, I'm running out of memory, I need to go collect objects that are no longer necessary. So I did come across this special static method, system.gc. It's not a great programming practice to use this. What it does is it requests that we try to run the garbage collector right now and make a best effort attempt at collecting all the objects that are available for garbage collection. So even by doing this, I can't guarantee for sure that all of the objects will get garbage collected before we get to line 39 and 40 to print out the new count. So let's go ahead and give this a run again and see what the end result of the program is. You can see here that I printed out the employee names Susan Baker and Bob Blue, and you can see in fact exactly what I was saying. Employees after system.gc is 2. So what happened here is we requested that the garbage collector run, but before we could even have that happen, the last line inside of main, scrolling down here, this last line that's highlighted inside of main went and printed out the current count, employee.getCount, and it still showed 2 because the 2 objects had not yet been garbage collected. But you can see that they were garbage collected right before the program terminated, and you can see the count decrementing by 1 when the first object was collected and decrementing by 1 again to 0 when the second object was collected. And I know they were collected because the only time the finalizer gets called, which is what's printing this out, is when the garbage collector calls it just before collecting the objects from memory. So again, we have a couple of concepts in this example. We have the concept of static data and static methods, and I will reiterate that when you invoke a static method, it is a poor programming practice to use a variable name of the class type to invoke the method, because you cannot tell from this method call that getCount is actually a static method. You should always use the class name and a dot to access a static member of a class. And then separately, the other key thing is if in fact you know you no longer need a particular variable that refers to an object, it would be a good programming practice to assign null to that variable, especially in a program that continues running for a long period of time, because that can help the garbage collector reclaim other objects. And then finally, it's not generally a good practice to call system.gc, but it is a way to suggest that the garbage collector should take its opportunity to run. You might do that if you know you're going to have a lull in program execution and you kind of want to get it done so that you can reclaim some objects.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.